Hello dear students, welcome back to NEET World. So today in this session we will be discussing very short answer type questions from organic chemistry, and this session is highly helpful if you are preparing for IPE exams from both Telangana and AP states, okay, right, and this is particularly from class 11th organic chemistry, like 2 marks questions we can expect from this discussion, okay. And before that, see, before going to start our discussion, see, this is our C60 material. Now you can access this C60 material for free of cost from our NEET World app. Just go to Play Store and download NEET World app, okay, and log in using your mobile number. Then you just mention your class and group in the chat box, okay. Then our team will guide you how to access this material for free of cost from our app itself, okay. Now you can utilize them and make your preparation more effective and productive, okay, right. See, whatever there in the material we are explaining in this live discussion, so that students who got this material from the app now open that and just go through line which I am explaining here, so that you will feel more easy and clear understanding will be there right now, right. So let's continue our discussion. So right, today we will be discussing 2 marks question from organic chemistry, and I hope you know that from this organic chemistry we can expect one 8 marks question, that is LEQ question, and here we can also expect a 2 marks question in this discussion itself, from this discussion itself. Mostly the question will be on IUPAC nomenclature, okay, right. Let's see some questions. Okay, so look at this. Write the structural formula of the following compounds. See, there are 4 compounds given and asking us to write their structures, okay. By looking at the name we need to write their structures, okay. It's very simple, just listen to me what I am doing here. Yeah, let me change the colors. See, first one is 2-methyl propanoic acid. So propanoic acid, this is the main chain you should remember here. So propane, so it means 3 carbon, meth means 1, eth means 2, prop means 3 now. So propane, N is there, so it's an alkane. So propane means 3 carbon should be there, and oic acid means the first carbon should contain a carboxylic acid, okay, that's it. See, propanoic acid is this one, okay. Now what they are asking, 2-methyl, so this is 1, this is 2, 3, so at second position you can write a methyl group. So 2-methyl propanoic acid, that's it. So this is the structure of the compound A. So here we have the structure, again I have mentioned here clearly. So both of them are correct way of representation only. So the next here, what we have, 2,3 dichlorobutane. So butane they are saying now, so just write it like this. So butane, 4 carbons are there, N, alkane, okay. So 2,3. So at second position, see 1, 2, 3, 4 if we number like this. So at second position chlorine, at third position also chlorine. So 2,3 dichlorobutane, yes, see 2,3 dichlorobutane. So second compound also completed. The next one here, trichloroethanoic acid. So trichloroethanoic acid. So there are 3 ethanoic acid now. So ethane means 2. So 2 carbons are there. So out of which 1 should be carboxylic acid carbon. Okay. So 1 is over, and the second carbon here, adjacent carbon, this is 1, this is 2 now. So on the second carbon we have 3 chlorines, okay, and here we have 3 chlorines, okay, like this you need to mention. So 1, 2, so 1, 2, so 1, 2 positions, okay. So at second position, see, trichloroethanoic acid, yeah. So here I have represented a structure, okay. So if you open the PDF from our app, you will be seeing like this, okay. Whatever mentioned I am explaining here, okay. See, so that you will feel more confident when we explain whatever the line we have mentioned in the book. Same thing if I explain here, you feel more clear understanding right now. So that's why we are trying like this, okay. So the next one is here, neopentane. What is this, a neopentane? Yeah, so you need to know what do we mean by isopropyl, secondary butyl, isobutyl, and neopentane, this kind of structure. See, they are saying neopentane now, so you just put a middle carbon. So pentane means 5 carbon should be there now. So out of that, 1 carbon I am placing middle, and 4 other methyl groups. So carbon valency, 4 valency is satisfied, other 4 methyl groups like this. See, like this. If you see, this is a neopentane. What is this? Neopentane. Yeah. So I hope you got the structure of neopentane. See, in the methane, you know, CH4 means methane. So remove all hydrogen and place methyl groups. That's it. We are going to get like this. See, how many carbons are there? 1, 2, 3, 4, 5. Okay. Now, what is the IUPAC name of this neopentane, you can say? So 1, 2, 3 now. So 2 comma, like see, at second position we have 2 methyl groups. So 2 comma 2 dimethyl propane is its IUPAC nomenclature. Okay, right. So up to here first question is clear. Right now, yeah, students, if you are clear with this explanation, just click on the like button so that I can confirm that you are following the session effectively. Yeah. So the next one here is write the structural formula of the following compounds. Again, next question is also writing the structural formula for the given compounds. Okay. So first one is what? 3 bromo 4 methyl heptane. So heptane means how many carbons? 7 carbons. So write them as 7 carbons like this. Yeah. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes. 6 is over. So it's 3 bromo 4 methyl. So 1, 2, 3. So 3 bromo 4 methyl. So 4 methyl. That's it. See, 1, 2, 3, 4, 5, 6, 7. So 3 bromo 4 methyl heptane. Okay. So this is the structure for the given compound A. Okay. The second one here is 2 methyl 1 butene. Okay. So 1 butene means butene. So 4 carbon should be there. Ene. So 1 double bond should be there. 1 pi bond should be there at first position. So butene. Okay. And 2 methyl. So 1, 2. Yes. Here you can write methyl group. So 2 methyl but 1 ene. So 2 methyl but 1 ene is a perfect name for the compound. Okay. So I hope you got this structure. The next one here, 2 amino propanoic acid. So 2 amino propanoic acid. So propane. So 3 carbon should be there, and one of it should be the carboxylic acid carbon. 1, 2, 3. Okay. So propanoic acid at second position amino group. So here we have NH2 group. So 2 amino propanoic acid is the structure of the compound 3. Okay. And here we have D as 2, 3 dimethyl hexanal. So al, hexanal. It means it's an aldehyde, hexane. So 6 carbon should be there. Yeah. So 1, 2, 3, 4, 5, 6. Yeah. 6th carbon should be like here. The carbon should contain one of this chain, parent chain should contain an aldehyde carbon. Okay. Yeah. So from aldehyde only we need to number 1, 2, 3, 4, 5, 6 because it is a principal functional group. Okay. And the next 2, 3 dimethyl. So at second position 1 methyl, third position another methyl. Yeah. This is how you need to draw the structure for D. Okay. See, whatever I am writing here, same structures are provided here in a proper indicator. Condensed formulas also mentioned here. You can just follow them, or if you are feeling easy to remember, yes, you can do the following these things also. Okay. Right. The next one here is 2, 4, 4, 5 tetramethyl heptane. So heptane means how many again? 7 carbons we know. So heptane, you write the first structure, write the structure of heptane first. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. So at third position 1, 2, 3. At third position 1 methyl. At fourth position 2 methyls. Okay. At fifth position 1 more methyl. So 3, 4, 4, 5 tetramethyl heptane. So this is the structure of this compound E. Okay. Hope the discussion is clear. Up to A, B, C, D, all structures are written here. Okay. Clear now? Let's move forward with one more question. Right. Let's move. Yeah. So the next, previously they have given the names and asked us to write the structures. Now here they might be giving you the structures and asking us to write the names. How can you write these? First of all, identify longest hydrocarbon chain. Okay, after identifying longest hydrocarbon chain, give the priority numbers by following least locant rule. Means substituent should get a lowest number possible. See, if I go from here 1 2 3 4 5 1 2 3 4 5. So if I go from here 1 2 3 4 5 1 2 3 4 5, yeah. So this chain also 5, this chain also 5. So how do we give numbering then? So now you need to follow that the parent chain should contain maximum number of branches. Okay, so if I consider like this, we have only one branch, but if I consider like this, we have two branches. So I am numbering it from here 1 2 3 4 5 like this. Okay, so at second position methyl, at third position ethyl we have, and is a parent chain here we have a pentane. Okay, so now how can we write the name? So ethyl, E, methyl, M, which comes first as per alphabets? So we know alphabetical order, E comes first. So you should write 3 ethyl, first letter should be capital. So 3 ethyl. Next here 2 methyl. Okay, 5 carbons are there, pentane. Like this. This is the name, IUPAC name of the compound. See, here I have mentioned 3 ethyl, 2 methyl, pentane. That's it. And how can we write this? Again, what I told you, follow the same steps. Identify the longest hydrocarbon chain, decide the longest hydrocarbon chain with maximum number of carbons. If carbons are same, follow the more the number of branches, more is the more is a priority. That should be considered as a parent chain. See, if I go from here to there 1 2 3 4 5 6 1 2 3 4 5 6 1 2 3 4 5. So 6 means this is a parent chain we have. So at second position we have, see, 1 2 3 4 5 6. Okay, from this side also this methyl group comes 6, but ethyl, so you can give E as a first letter, first number. Okay, so what you can write? So 3 ethyl again, so 3 ethyl, 4 methyl, 3 ethyl, 4 methyl. Okay, hexane, 6 carbons are there, hexane. There is no space between the words here. Okay, right. So 3 ethyl, 4 methyl, hexane, that's it. These are the names for the given structures. Okay, hope this question is also clear. Let's move forward. See guys, whatever I have included in this material, all of them are previously asked questions only. Okay, so we know in IPE mostly questions will be repeatedly asked. So that's why I have considered all the previous year questions to be included here. Okay, most repeated questions first as per the priority order I have included here. Okay, right. Let's move forward. Write the IUPAC names for the following compounds. What is the IUPAC names for this given compounds they are asking? So how can we write? So just give the number, identify the longest chain. Here we can say 1 2 3 4 5, that's it. It's a pentane. At second position 2 comma 2 dimethyl. See, 2 comma 2 we have, and 3 also methyl only. So 2 comma 3 trimethyl pentane. So 2 comma 3 trimethyl pentane, that's it. Structure A is done. Next one here. So here we have a principal functional group. Now assign the number 1 for that. Okay, and come this side 2 3 4. At third position we have dimethyls, 2 methyls. So 3 comma 3 dimethyl, butanoic acid. So 3 comma 3 dimethyl butanoic acid is the name of that compound. Okay, right. So this is also clear now, right. Let's move forward. Look at this again. Write the structural formula of the following compounds. How do you write the structural formula for these? See, heptane. So heptane means 7 carbons first. 1 2 3 4 5 6 7. Okay, so 3 comma, so let us say 1 1 2 3. So at second position, third position 3 comma 4 comma 5. Okay, so 3 4 5 6 7. So 3 comma 4 comma 4 comma 5 tetramethyl heptane, that's it. This is the structure. Okay, you can write in this way or this way, both of them are perfect. Okay, so the next one here 2 methyl butene. So second position you can keep this methyl group, that's it, of this butane chain. Okay, next here if you see sixth question here, write the IUPAC names for them. So how do you write? So just identify like longest chain here. 1, 2, 3, 4, 5. That's it. So at second position we have 2 methyls. In fourth position also 2 methyls. So 2 comma 2 comma 4 comma 4 tetramethyl. What is this? Tetramethyl. 5 carbons in the parent chain. Pentane, tetramethyl pentane. That's it. This is the IUPAC name for the compound. Okay, right. So yeah. So here clear explanation also provided for your understanding, but anyways I have given this. Identify the parent chain having maximum number of carbons. Okay, then identify the substituents whatever we have. Okay, they should get a minimum number possible. Okay, the sum should be the number sum. This sum should be a minimum. Okay, then that should be considered as a perfect numbering and ordering. Okay, and while writing the names, follow the alphabetical order for the substituents. Okay, right. So this is clear, and for this, see here we have OH group on second carbon. So it means you should number from this terminal, because the substituent or the principal functional group should get a minimum number possible. So 1, 2, 3, 4, 5. So second position OH group means alcohol. So you can say pentane 2-ol or 2-pentanol is the IUPAC name of this compound. Okay, right. So yeah, so 2-pentanol or pentane 2-ol is the IUPAC name for the given structure. This is done, and the next one here we have for these compounds. Yeah, now you can understand. I hope you got this clarity, like how can you write names in case of alkanes, alkenes, right? So here we have one more alkene. So write number from here 1, 2, 3, 4, 5. See, I am numbered from this functional group alkene side, so that should get a minimum number. So 1, 2, 3, 4, 5 now. So pentene. So pentene or 1-pentene, both of them are correct only. Okay. So now 1-pentene is the name of this first compound. Second compound, if you check how it is mentioned, see CO is there. So CO means it's a carbonyl group having methyl group one side and another side ethyl group CH2, CH3. So number it from that terminal side which gives a lowest number to the carbonyl group. 1, 2, 3, 4. So 4 carbons means bute. Second position carbonyl group is there. It's a ketone. So the name of this ketone should be written like this. 4 carbons are butane 2-one or 2-butanone. 2-butanone. These are the IUPAC names you can follow for this compound. Okay. So AB also clear here, right? So here I have mentioned 2-butanone. Both of them are correct here, which I have mentioned, right? The next one here, write the IUPAC names for this compound again. So based on the explanation, what you can see, give the numbering from any of the side. Both of them are ethyl groups only. You can follow from any of the side. 4, 5. So here at third position carbonyl group is there. So 3-pentanone is a IUPAC name for this compound. What is that? 3-pentanone. That's it. Okay. Now when it comes to this one, so 1, 2, 3, 4. So 1, 3 butadiene. What is the name of this compound? See at first position double bond, at third position double bond. It's a 4-membered chain. So butane, like 1, 3 butadiene. What is this? Butadiene. Okay, this is what you need to write. 1, 3 butadiene is the IUPAC name. Okay. Now what about this compound? So what about this compound? So how many carbons are there? Yeah. So whatever I have mentioned in the first structure similar to this third one. So you can write the same name for them. Okay. Right. Next. Here 8th question we have. The question says write the structural formula of the following compound. So 4 compounds is given and we need to write the structural formula. So if you have followed, I already explained for these 2 compounds. See again the names are repeated. Trichloroethanoic acid, the first or second question that we have discussed. Neopentane, this is already covered. Now extra compound here they have mentioned is para-nitrobenzaldehyde. It means benzaldehyde means you just write it as benzene ring with an aldehyde group. So this is called benzaldehyde. So para, it means the adjacent position to this aldehyde group is called ortho. These positions are called meta. So 1, 2 are ortho, 1, 3 is called meta, and 1, 4 this is there now, it is called para. Okay, so since in the question they are asking about para, so what you need to do? So at para position, at fourth position you need to insert a nitro group, that's it. Okay, so this is your 1, 4, I mean 4 nitrobenzaldehyde or para nitrobenzaldehyde. This is the final name or the final structure of this compound C. Okay, done. Next, let's move forward. So here write the conformations of ethane. Again this is easy and important now. So what are the conformations we can write for ethane, they are asking. Okay, so ethane show 2 important conformation due to free rotation of CC bond. See, first of all, what is the formula of ethane we know? CH3, CH3, right? So let me change the color of the pen. CH3, CH3, 1, 2. So these are the 2 carbons. Like we can rotate this sigma bond present between the C and C, like 2 methyl groups. By rotation of that sigma bond, CC rotation is possible whenever there is a single bond, sigma bond. Okay, so due to that rotation we will get different structures or different, I mean not structure, conformers. Okay, so those are considered to be conformations of this ethane. Okay, so by rotation of this bond. So for better understanding, let us say this molecule, I am saying this first carbon as a dot. Okay, and on dot, I mean this carbon is indicated with a dot. Okay, and this second carbon is indicated by circle. Consider like this. Okay, so dot indicates what? The first carbon. Okay, second carbon indicated by circle. Now on this first carbon 3 hydrogens are there now, so let us write them like this: hydrogen, hydrogen, hydrogen. It means this dot indicated first carbon. Okay, and 3 hydrogens on first carbon are like this, and second carbon is indicated by circle. On that carbon also we have hydrogens, right? So let us say this is a dot, this is a circle. So on this dot 3 carbons are there now, yeah, I have mentioned them like this. So at the exactly, if this is 1 hydrogen, exactly backside 1 more hydrogen on the second carbon we have. So it means this is the backside indication. So angle between these two are called dihedral angle. So the dihedral angle here is 0. It means this hydrogen and this hydrogen are like this. So you are, I think you are able to see only first hydrogen, this first index finger, not the backside one, right now. So angle between these two index fingers is how much now? 0 degrees. That is called dihedral angle. So whenever we have like this kind of scenario is called eclipsed conformation. What is that called? Eclipsed conformation. So in eclipsed conformation, theta is equals to 0. Okay, right. So like that I can represent all 3 hydrogens on both methyl groups, on both methyl group carbons. Okay, like this. Okay, and after doing this, now what I am doing is I am just rotating 60 degrees one of this carbon. See, first carbon, the dot carbon I am keeping as such, but second carbon I am rotating here backside. So this circle is rotating. So just consider it like a car steering and you are rotating it with 60 degrees. Now what happens, tell me? With 60 degrees means hydrogen, hydrogen, hydrogen. So this red color hydrogens are rotating like this. So it becomes exactly here and exactly here, and one more hydrogen exactly here. So the first one, where do we have this angle theta is equals to 0? This is called eclipsed conformer, eclipsed conformation. Okay, in eclipsed conformation, what is the dihedral angle? 0. So when we rotate 60 degrees, we are getting one stable conformation. This is called staggered form. What is it is called? Staggered conformation. Okay, so what is the dihedral angle here? 60 degrees. It means between this dot carbon hydrogen and the circle carbon hydrogen, it means this one. Between this red color hydrogen and this yellow color hydrogen, what is the angle we have? 60 degrees. Okay, so that is what we are calling it as a dihedral angle in staggered conformation is 60 degrees. Okay, like this. So 0 degrees means eclipsed. Okay, eclipsed. Okay, now I will tell you what are the angles possible for eclipsed and what are the angles for staggered here. This is an extra discussion I am doing. So eclipsed means 0 degrees, again 60 degrees means staggered, again you are rotating 60 degrees. What happens now, tell me? Both this hydrogen again goes back side of this yellow color hydrogen. It means again it gives you eclipsed conformation, that is angle is how much? 120. Again if you rotate, that becomes 180, that is staggered conformation. Again if you rotate 60, becomes 240, that is eclipsed conformation. Okay, again if you rotate 60 degrees, you are going to get 300 degrees, that is staggered conformation. Again if you rotate again 60 degrees, you are going to get, that is 360 is nothing but 0 now, again it can be considered to be eclipsed. So these are the angles, dihedral angles, where you will get eclipsed conformation of in ethane, and these are the angles you will get a staggered conformation of ethane. Okay, remember these points which I have highlighted here. Okay, so these are useful, very useful in case of competitive exams like NEET, JEE and EAP set. We can expect a question from here directly. Okay, now other than these two angles, what I am saying, other than these two angles, see, instead of rotating 60, now I can rotate some 20 degrees, 30 degrees, 5 degrees, 10 degrees, like other numbers are possible now. So all that conformations by rotation of some angle other than these angles, we can call them as skew geometries or skew conformations. What we can say? Skew conformations. So there are three conformations possible for ethane. What are those? Eclipsed, staggered, skew. So out of these three, staggered conformation is highly stable. Which is more stable? Staggered form is highly stable. Staggered is highly stable. After that, skew conformation, and least stable is for eclipsed conformation in case of ethane. Okay, these are the things to be remembered. And you know, this circular representation, whatever we are representing like this is called Newman's projection. What is this called? Newman's projection. Okay, so conformations can be explained in these two ways. One is Newman projection, other one is Sahar's projection. So we have used here Newman's projection. So in this way, if you represent, this is called a staggered, this is called Sahar's projection. What is this? Newman's, this is Sahar's. Okay, and one more we have Fisher projection. Anyways, in the exam they are focusing on these two. Hope you got this concept. One is Newman, other one is Sahar's. Okay, right. If the discussion is clear, whatever we did, so just click on the like button, and if you are new to this channel, please click on the follow button also. Okay, right. You can share your feedback in the chat box, whether you are able to follow this or not, or any confusions are there, or you want me to discuss any other topic here particularly. You just feel free to mention it. And the next question, how is nitrobenzene is prepared? So it's very simple, ma. So take benzene. What you need to take? Take a benzene. So treat this with concentrated nitric acid along with sulfuric acid. So you are taking a mixture of nitric acid and sulfuric acid. So this reaction is carried out at 60 degrees Celsius. Okay, and that gives you nitrobenzene. Okay, this is the nitrobenzene. Okay, just read this. When benzene is reacting with concentrated nitric acid and concentrated sulfuric acid at temperature below 60, it forms a nitrobenzene. That's it. Okay, so this reaction is called nitration of benzene. That's it. Okay, nitration of benzene gives nitrobenzene. Now, if you want to write one extra point, that what is the electrophile in this nitration of nitration of benzene means it is a nitronium ion. NO2 plus is the electrophile. That's it. Since it is a 2 marks question, like this, if you mention, you will get the full marks. Okay, right. Hope the discussion is clear. If everything is clear, just click on the like button, and you can follow us for more such content. And you know, so these are the 11 questions I have picked from the previous year papers. Okay, first you cover this, and if you have time, just focus on the other topics also, other questions also. I hope this session is highly helpful, and thanks for watching. Stay connected with our NEET World YouTube channel. Thank you.